Hi, everyone. So my application of LLMs is a bit more focused on one particular task. I think Connie or Chrissy asked a bunch of people if they had any experience using LLMs for talks, and this was something that I'd been working on, just a day or two before. So I thought I'd share my experiences with it. So this work happened within the context of the OASIS consortium. So I thought I'd just give a slide or two on what that is so that everyone knows. So it's a group of a whole bunch of different ag chem pharma companies, government agencies, academic institutions, and nonprofits. And our goal is to test a combination of cell painting, transcriptomics, and proteomics in a variety of cell models for safety assessment, focused on hepatotoxicity as a test case. So the overall kind of big picture of what we're working on is that we started by searching the literature and various databases out there for all of the compounds with published in vivo liver tox data in either rats or humans. That also could be conveniently ordered from just a small number of chemical vendors. So this gave us about 1,500 compounds. We're next exposing them in increasingly complex liver models, so different cell lines, and then many smaller in organoids and organ-on-a-chip models. We're collecting cell painting data for all of them, a panel of transcripts for most of them, and then a panel of proteins for a smaller subset. And then we're trying to, do comparisons with the concentrations that cause in vivo hepatotoxicity, but then also try and predict specific types of in vivo toxicity. So on the left, way over here, we've had this figure for forever, but we have all of these kind of various hepatotoxicity outcomes. But it took us a really long time to actually get a comprehensive curated source of this information. You might find different lists in different particular papers, but it's not always clear, where exactly those classifications come from. Um, so what helped us a lot was ToxValDB, which is a database curated by the US EPA, where they harmonized in vivo testing data across about 40 different sources. So they did a ton of really difficult work of going through all of these often PDF reports to pull out this key experimental metadata that describes each of these different guideline toxicity testing data sets. And they took out the dose response summary value, so the concentration where they saw an effect. And so the version that I was using was 9.6.0, and there they had over 230,000 different records across almost 40,000 different compounds. And then they extracted that experimental metadata in a harmonized format, and then also these dose response summary values. So the data looks like this. This is just a screenshot of a table that I pulled out of ToxValDB. And so it has all of this harmonized metadata, like the compound name, the data source, what type of dose response summary value it is, the concentration, units, study type, and all of this is mapped to harmonized vocabulary, which is really helpful. But you'll notice that the toxicological effect on the far right-hand column, this one is not harmonized. This is short phrases that were either, I think they're either extracted directly from the reports or manually written in there. And you can see that they are descriptive, but they are not consistent or the same. So each source has its own vocabulary. And so this is kind of what we wanted. We wanted to capture all of this in vivo toxicity testing data. We wanted to use it as labels for our omics data to be able to start trying to predict specific outcomes. And there's already so much work done to get it to this point, but it was tackling this column on the far right that was what I turned to ChatGPT to help me with. So I started with a bunch of kind of manual just filtering and text processing. So we started with all 230-ish thousand records. We first filtered to look for all of the ones with an oral exposure. So that got us down to like 71,000. We were looking at rat because we had decided as a consortium to focus on rat in vivo guideline testing data. Um, I just did some substring searches, so I filtered to keep any toxicological effect that contained liver, hepatic, or biliary, and that dropped it to 6,300 records. I filtered to our compounds that we ordered through OASIS, and this gave us almost 2,400 unique toxicological effect strings. You can see though that they're separated by this consistent little character here. So if I split by this and then get to unique, I now have 265 unique effect terms. So the task was to try and map these almost, 300 terms to a common set of categories that we could use to start analyzing our data. So what I did is I did sort of back and forth with ChatGPT. So I manually defined four large categories: liver weight, clinical chemistry, gross pathology, and then histopathology. And then I took all of the terms and in batches, I just pasted them into ChatGPT and asked it to map each term to each of the four categories. Um, and then for each of those larger categories, I pasted the terms into ChatGPT again in batches of 50 and asked it to come up with sensible subcategories. So I told it to avoid categories with a single, well, not avoid with a single term. I wanted it to come up with like biologically relevant groupings. Um, and then I also asked ChatGPT for substrings that sorted the terms into those categories. And with this, I wrote a Python script based on the substrings to reproduce the sorting. So now the whole logic is captured, it's in a GitHub repository, and you can rerun it. So there's a record of how this was done. And then I also asked ChatGPT to map all of the TG gates and drug matrix terms or descriptions onto this hierarchy. So this, in the end, gave me a pretty sensible mapping. I spent some time manually cleaning up difficult phrases. So some of the times, whatever processing of the effect descriptions, it didn't work perfectly. And so sometimes there was multiple endpoints in one term. So I would kind of manually split those. I sent my initial term map to other people for expert review. So Arun Pandiri helped with this and kind of looked at everything that myself and ChatGPT had done together. He changed maybe 15% of the mappings. Most of these were like nothing was really incorrect. It was just some of these categories could be more informative if they were split into more fine-grained categories. For example, a whole bunch of them he annotated with a specific cell type and split into smaller categories, and then also combined some small categories into groups that he thought maybe were more meaningful together. I did a final review and the result was about 61 terms. And so you can see in our OASIS screening library, we have this number of compounds that showed this type of toxicity in rat testing data. This allowed me to quickly make this heat map, looking at the co-occurrence of all of these toxicity endpoints and doing a little bit of clustering. Of course, we have to take this with a little bit of a grain of salt because you're not sure that each of the 40 sources actually assessed all of the outcomes. So especially some of these more specific histopathology outcomes, it's possible that they existed, but that they just weren't assessed for those types of endpoints. And I need to think more about how to deal with that. I used pairwise Jacquard index to look at the overlap or the co-occurrence of these different endpoints. And I thought this was kind of interesting. These were the top co-occurring terms altogether. So absolute increase in liver weight, hypertrophy, and hyperplasia, which makes a lot of sense, but then also cell death. Um, so my conclusions from this work was that ChatGPT greatly sped up the mapping process. I don't know if I would have had the courage to tackle that list of about 300 terms on my own and try to come up with a scheme of organizing them. But this is with a whole bunch of caveats. That's first, there was an enormous amount of effort that went into curating ToxValDB to get it into that format to start out with. There was text pre-processing and post-processing by me in Python. There are multiple layers of manual review. Um, The labels in the future will be used in our work to train machine learning models based on the omics data to try and see if we can detect a signature or discriminate compounds with these effects from those that don't. And they'll also be useful for selecting compound subsets for assessing these advanced liver models. For example, if an advanced liver model is designed specifically to detect toxicity that involve two specific cell types, for example, we should be able to use these more curated labels to pick the exact compounds that we want to look at. based on all of this prior toxicity testing data. And this pipeline didn't take that much effort, so I think it might be worthwhile to apply this to more categories of entries or for more compounds than just the OASIS list.